I have come back to the same program which we went from where we ended actually last time. If you remember, this program was basically 1 factorial plus 4 factorial plus 9 factorial plus 16 factorial plus dot 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 dot. How long will it continue? It will continue up to n square factorial, Now what is this? If you look into this carefully, then 1 factorial is 1 square, 4 factorial is 2 square, 9 factorial is 3 square, 16 factorial is 4 square, 16 factorial is 4 square factorial, 9 factorial is 3 square factorial. In this way, last one is n square factorial. Now see, the thing is that what you did was you scanned the n. Now in a loop you called the fact function, passed it I into I, that is I square, and then factorial of that was computed. So initially I is 1, so 1 square factorial computed, next time 2 square factorial computed, next time 3 square factorial computed, and every time it was added to sum. Now the problem that occurred was this sum might be huge, and the result of this fact might also be huge, like 9 factorial is a huge number. Now integer cannot accommodate that number. In that I taught you, which I will very quickly recapitulate because it's a very important point. If you remember, if you have 1, it means 1. If you have 2 1s, then it means in binary it is 3. 2 1s you can check out. How do you check that in binary? You remember 1, the next weight is 2, the next weight is 4, and the next weight is 8. So 1 means 1, 1 means 2 plus 1, 3. Similarly 1, 1 and 1, 1 and 1 should mean 4 plus 2 plus 1, that is 4 plus 2 plus 1 makes it 7. So 1, 1, 1 definitely is 7. Similarly, if you think of 1, 1, 1, 1, then 1 is 8, 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15, so 1, 1, 1, 1 is 15. Similarly, the next weight after 8 is 16, is right? So after 8 is 16. So if we have 1, 1, 1, 1, 1, then it will mean 16 plus 8, 24 plus 4, 28 plus 2, 30 plus 1, 31. I repeat, 16, this one is 16. So 16 plus 8, 24, 4, 28 plus 2, 30 plus 1, 31. So definitely this will mean 31. Now what I want to point out is, see, 1 is 2 minus 1, which you can also say is 2 to the power of 1 minus 1. 2 minus 1 is as good as 2 to the power of 1 minus 1. 3 minus 1 is 4, 3 is 4 minus 1. 4 is 2 square. So it is 2 square minus 1, 2 to the power of 2 minus 1. Similarly, this is 7. 7 is 8 minus 1. So definitely this is 8 is 2 cube. It is 2 cube, 2 to the power of 3 minus 1. Similarly, this is 15. 15 is 16 minus 1. That is 2 to the power of 4 minus 1. Similarly, 31 is 32 minus 1. 32 is 2 to the power of 5. So this is 2 to the power of 5 minus 1. So see, 1 bit, 1 is 2 to the power of 1 minus 1. Next is 2 1s, 2 to the power of 2 minus 1. Next is 3 1s, 2 cube minus 1. 4 1s to the power of 4 minus 1, 5 1s to the power of 5 minus 1. Similarly, if there are n 1s, so this should be 2 to the power of n minus 1. Is not it so? If there are n 1s. Now what I wanted to point out is, when you write int a, it immediately means 2 memory locations are allocated for a. 2 memory location means each memory location is 8 bits. So 8 bits means int is how many bits? 16 bits then. Int a means 16 bits are allocated. In 16 bits, how many 1s can be there? You may think there are 16 ones, but the first bit is 0. So first bit is 0 means how many ones? 15 ones. So first bit 0, 15 ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Isn't it so? 15 ones. First bit is 0, followed by 15 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 bits are there. So if 15 bits are there, 0 followed by 15 ones is 2 to the power of 15 minus 1. So the maximum number that can stay 2 to the power of 15 is 32768 minus 1. So what is the maximum positive number that can stay in an integer? 32767. I tried to explain you this whole thing in the last program, in the last discussion rather. Now if you declare it as long int a, instead of int a, if you declare it as long int a, then what happens is this a allocates not 2 but 4 memory locations. I think you understand this. Instead of 2, it allocates 4 memory locations. So 4 memory locations means each memory location is 8 bits. So each memory location is 8 bits means 4 memory location is 32 bits. So 32 bits. 32 bits means 0 followed by how many ones? 31 ones. Isn't it so? 31 ones. So 31 1 means it is 2 to the power of 31 minus 1, which is then a huge number as compared to 32768. It's a huge number. So a big number can stay within that. Now the problem in fact is, if you say 4 factorial, it is 24, 5 factorial 120, 6 factorial 720, 7 factorial is 5040, 8 factorial it is more than 40,000, but the maximum number that can stay in an integer is 32,767 as I told you. So in an integer even 7 factorial can stay, but an 8 factorial cannot stay within an integer. Even if you write 8 factorial, it is too big for an integer. So what I did was, I tried to put this product or the factorial value in a long int so that it can now accommodate the big number. So I kept on in multiplying this I, that is 1, 2, 3, 4, 5, 6 and so on with this product, and that this product can accommodate a huge number. If you return this product, you are returning a long int. So the return type of this was long int. This was the discussion of the last session. Now in this session, if I just change this program a little bit and do a new thing, let's get rid of this part. I think you have understood this whole thing. You have understood the concept of long int. I will now just simply delete this whole part. Now a new program. This time what I will do is 1 factorial, okay. Actually what I want is 1 to the power of 1 factorial. I think you understand. Next what I do is 2 to the power of 2 factorial, that is 4 factorial. Next, not 3 square, so what will it become? 3 to the power of 3 factorial, that is 27 factorial. So the program given to you is to compute something like this: 1 factorial plus 4 factorial plus 27 factorial. Isn't it so? Then maybe 4 to the power of 4. 4 to the power of 4 is 16 into 16, that is 256. So 256 factorial and so on. So what will be the last term that you have to use? If n is entered, then the last term is n to the power of n factorial. Is not it so? This is n to the power of n factorial, and this is not 16 factorial, this is 4 to the power of 4 factorial. Now how to calculate this? For this you can easily do one thing. See, over here you have called this scanf percent ampersand and everything you have done. Now what will you add with sum? See, first thing you need to do is I to the power of I. So can I call a Pow function where I and I passed, expected I to the power of I will be returned? So can I receive it in X? I think you understand this. And then what I can do is factorial of y, I can say y equal to factorial of x. Please understand what I am trying to do. I am trying to do is I am calling the Pow function, passing I to the power of I. So I to the power of I means you have received I to the power of I in x. And then you are calculating factorial of x. So factorial of I to the power of I, that is what you want. In any case you want I to the power of I. When I is 3, 3 to the power of 3. When I is 4, 4 to the power of 4. So I to the power of I, then the factorial. So I am doing exactly that, I to the power of I. Then I am calculating factorial of that. And then with sum I can add this, I can simply add this y. I think you understand this simple logic. So I need a Pow function, I need a fact function. Fact function is already there with me. Pow function you can use math.h. Math.h Pow function is written, or else you can write the Pow function yourself, not a big deal. You can do that easily. Now you can easily write such a program. But what I want to show to you over here is you can also have nested functions. Like if you call Pow II, then immediately the control goes to the Pow function. I to the power of I is calculated and then returned. Where is it returned? It is returned here only. The control with the value of Pow I to the power of I comes over here only. What if I now write fact of that? Easily possible. Nesting of functions is easily possible. I call Pow I to the power of I. So I to the power of I value returns over here. Whatever value returns I to the power of I, whatever is the value, I calculate the fact of that. That is, now you call the fact function with this value. How the control runs is, firstly it sees the inner function is Pow II. So firstly it calls Pow II. The value returns over here only. Once the value returns, then the outer function fact is to be computed. So fact is now calculated, fact is now called with this new value. I think you understand this. And whatever is this, you have to add it to the sum. I think you understand this. Whatever is this, you just add it to sum. So this is done now. You can now write the sum over here. And then you can simply write the sum over here. The sum of the expression is %LD sum, because sum also has to be declared as long, because factorial will be long itself. In fact, Pow should also be long. Let us write the Pow function also and get rid of this math.h. Programmers all across the world tend to avoid #include math.h and write the needed functions themselves, because math.h contains many functions apart from Pow and square root or others. All those functions will be unnecessarily be included in your program. Those are not needed. Only the Pow function is needed. Let us write that. Now Pow function, what will it receive firstly? It will receive two integers. So you can say it receives int a and int b. Is not it so? So what should it return? A to the power of b can be a big number. So long int. It should return long int. Like fact, n can be small. A small number's factorial is to be computed, but its result can be long. In the same way, this Pow int a, int b, a and b can be small, but its result a to the power of b can be quite long. So now you calculate a to the power of b and return that. How do we calculate? For a to the power of b means multiplying a b times. So for I equal to 1, product equal to 1, you initialize product equal to 1. Then I, how many times? B times, less than equal to b. A to the power of b means a to be multiplied b times. I less than equal to b, I plus plus. what will you do? You will simply multiply A with product. So A is multiplied not once, every time in the loop. Loop iterates how many times? B times. So how many times A is multiplied? B times with product. Product was initially 1. A multiplied with it B times. So it is A to the power of B. And what you do at the end is return product. Only catch over here is your I is integer, because I is maximum value can be B. B is itself an integer. Maximum value of I can be B. So I can go up to B, I can be integer, but the result can be, the product can be quite big. So this is long int product which you return at the end, so your return type is long int. But remember, your product variable over here has got nothing to do with the product variable over here. It is different. Okay, so this whole thing is done now. You simply now run this program and you get the I to the power of I factorial summation of that is 1 factorial plus 4 factorial and so on. Continued, this program should run absolutely fine. What you learn over here is a nested function. The nested function works fine. Let me now run this program. There is one small problem. I will run this program, but you try to understand the small problem. This pow, what does it return? It returns long int. Pow returns long int. What are you passing to fact? Fact receives what? Fact receives int. Please understand this. Fact receives int. You are passing it what? Long int y. To I and I that you are passing to pow, they are ints. No problem. I and I, they are integers. So what you are passing to pow is integer. That is matching. What is returning from pow function is long int. So what are you passing to fact? You are passing long int. What are you receiving in fact? You are receiving int. There is a mismatch. I think I could make you understand. Return from pow is long int. So you are returning a long int over here. No problems. Over here you are returning a long int, here you are receiving a long int. So this is what you are passing to fact. So what is the argument you are passing to fact? Long int. What are you receiving here? Int. Will it work? Will it show any error? It will not show any, sorry, this first part has to be firstly deleted, then it will not show any error. No error at all. Even if you write 3, it will show a big sum, it will show. But the problem is this 3 cube is 27. This runs and runs fine, because when you are passing 3 cube is 27. What is returning over here is long int. Long int's value is 27. So 27 mapped to int is 27 itself. But once this value is more than 32767, then passing it to fact function as an int will pass a wrong value. It will be mapped to an integer value less than 32767. Say this pow return from pow is more than 32767, which is possible because return from pow is long int. This is the return from pow, which is long int. You are returning product, which is a long int. But that long int, suppose, is more than 32767. So passing to fact more than 32767, receiving it in an integer will map it to a value less than 32767, which is wrong. So can we do one thing? Can we also receive this n as long int? Possible? In that case, I should also be long int, because I can go up to n, so I can also be long int. Should not be a problem. You may ask me a question, what if it also exceeds the capacity of long int? That can always happen. See, everything has got a final capacity. So the capacity of long int may also exceed at some point of time. After that, computer will not work. Today's computers are capable with more strength, with more power. So you can put in more bits. You can put in more bigger numbers. You can put in bigger numbers. You can put in numbers which are more big. But there is an ultimate capacity of everything. So long int has also got a final capacity. After that, it will not work. But at least In this function for values of 5, 6, 7, it will definitely work. So it is better to receive it as long int n, then also declare this as long int I can go up to n also. So now this program is this function is absolutely fine. So here also it is said that you can also do the other way around. Say over here you have done fact of pow, but in some other program you can also do the other way around, like pow of fact. Pow of fact, something you may do, pow of facti, but facti will return a long. If you pass it to pow, then pow receives an integer is wrong, but after that you have to send something else, because pow receives 2 parameters, so you need to send 2 arguments. But definitely this can be done, pow of fact something can be done. I think you understand this. So once this is done, once this you have understood, you also understand that that means is this facti, if it returns a long, passing it to pow in an integer is also wrong. That should also be long. So this also you make long. Long int A, long int B. And then this I cannot also be integer, then it has to be long int I followed by the product. That is also long int, because I will go up to B, B itself is a long int. So now this whole thing is correct. Only thing that you need to do over here is that over here this sum is long, this fact is long, so over here it should not matter. Your I is int, because your n that will be entered is expected to be a small number, and I will go up to n. So this int I and int can be integer, no problem. But your sum is already long int, and this is now calculating with long int. What you are printing is definitely a long int, because the sum can be long int. Now you run it. 4, a big number. 5, further bigger number. You can check all this. Isn't it so? So this thing works absolutely fine. You have understood what? You have understood in this whole discussion, you have understood a nested function. We'll come back with more functions, more function programs. We'll do more interesting programs. You may take a bit of break, and we'll come back soon. Thank you.